We live in a world awash in data. Every click, every sensor reading, every financial transaction generates a torrent of information. This data holds immense potential. It can fuel scientific discoveries, drive business innovation, and even help us understand the universe around us. But this deluge of data also presents a significant challenge. How do we store, manage, and analyze this vast and ever-growing sea of information? Traditional data storage methods struggle to keep up. They weren't designed for the sheer volume and complexity of today's data landscape. We need new tools, new approaches, and a new way of thinking about data itself. This is where the power of big data technologies comes into play. By harnessing these technologies, we can unlock the hidden potential within our data and use it to shape a better future. But it's not just about storing data, it's about understanding it. Imagine trying to study the ocean's currents with scattered buckets of seawater. You need a way to collect, filter, and analyze that water to reveal its secrets. Similarly, we need efficient ways to process and refine our data to extract meaningful insights. This is where the concepts of data pre-processing, normalization, and standardization become crucial. Just like a telescope helps us see distant stars more clearly, these techniques bring order and clarity to our data, allowing us to see patterns and connections that would otherwise remain hidden. Before the cloud became ubiquitous, we needed a way to handle massive datasets. Enter Hadoop, a revolutionary framework designed to process and store data across clusters of commodity hardware. Think of it as a giant, well-organized warehouse for your data. Hadoop's distributed file system, or HDFS, breaks down large datasets into smaller chunks, distributing them across multiple machines for parallel processing. This approach, known as pre-cloud extract, transform, load, or ETL, allows us to handle data volumes that would overwhelm traditional systems. Hadoop's power lies in its ability to handle unstructured data, the kind of raw, messy information that comes from social media, sensor networks, and other real-world sources. It provides a platform for cleaning, transforming, and preparing this data for analysis. Imagine trying to assemble a puzzle with millions of pieces scattered randomly. Hadoop helps us sort those pieces, identify the edges, and begin to see the bigger picture. By pre-processing data with Hadoop, we make it more manageable, more meaningful, and more valuable. Now that we've wrangled our data with Hadoop, it's time to refine it further. Normalization and standardization are essential steps in this process. Think of it like preparing ingredients for a complex recipe. Before you can combine them, you need to chop, slice, and measure everything precisely. Similarly, normalization and standardization ensure that our data is consistent and comparable. Normalization involves scaling data to a common range, often between 0 and 1. This eliminates the impact of different units or scales, allowing us to compare data points fairly. Standardization, on the other hand, transforms data to have a mean of 0 and a standard deviation of 1. This ensures that all features contribute equally to the analysis, regardless of their original scale. By normalizing and standardizing our data, we remove biases and inconsistencies that can skew our analysis. It's like polishing a lens to remove smudges and scratches, allowing us to see the world with greater clarity. These techniques are crucial for building robust and reliable machine learning models that can extract meaningful insights from our data.